Every day we see the sun rise and set. We live on a planet that orbits it. We look up and find the moon, the stars, and sometimes even other planets shining in the night sky. Together they form what we call our solar system. The sun, the planets, their moons, asteroids, comets, and countless tiny fragments of dust and rock. 4.5 billion years ago, there was only a giant molecular cloud, a vast collection of hydrogen and helium left over from the Big Bang, mixed with heavier elements like carbon, oxygen, and iron, which were the ashes of ancient stars. This cloud was enormous, stretching across dozens of light years. For millions of years, it drifted silently through the galaxy, until something disturbed it. Maybe the shockwave from a nearby supernova. Maybe the powerful winds of massive young stars forming close by. Whatever it was, the balance broke, and gravity took over. Slowly, the cloud began to collapse under its own weight. Clumps of gas and dust pulled tighter and tighter, and as they fell inward, the entire cloud began to spin. It flattened into a vast rotating disk, and at its centre, matter piled up into a dense, growing ball. And that was the first spark of what would one day become our sun. As the collapsing cloud tightened, the centre grew hotter and denser. Pressures climbed to extremes we can barely imagine. Atoms of hydrogen were forced so close together that they fused into helium, and in that instant, a new source of energy ignited. A star was born, our sun. Almost 99.8% of the entire cloud's mass was swallowed by this one blazing sphere. The rest was left behind, forming a thin, swirling disk around it. That leftover material may have seemed insignificant compared to the sun, but from it, every planet, every moon, every asteroid, and every comet in our solar system would be built. Inside the swirling disk around the newborn sun, each planet's story began in a slightly different way. Closest to the sun was Mercury. In this scorching region of the disk, lighter materials like water and gas could not survive. Only the heaviest elements remained. As planetesimals collided, Mercury grew dense and metallic. Its iron core became enormous, making up more than half of its volume. But with little atmosphere to protect it, the planet's surface was left battered and bare. Next in line was Venus. Built from rock and metal, Venus should have been almost identical to Earth. As it grew, volcanoes released gases into the air, building a thick atmosphere. But trapped carbon dioxide caused extreme greenhouse heating. Over time, Venus turned into the hottest world in the solar system, its surface pressure strong enough to crush a submarine. Then came Earth. Born from countless collisions, Earth reached the perfect size to hold on to an atmosphere without becoming a gas giant. In its early days, it was a fiery world, but constant impacts from asteroids and comets delivered water and organic molecules. Volcanic eruptions added more gases and slowly, oceans formed. Earth became a stable world with the conditions needed for life to emerge. Farther out, Mars was formed from the same rocky building blocks, but its smaller size made it fragile. Mars built an atmosphere and flowing water once existed across its surface, but its core cooled, its magnetic field faded, and the solar winds stripped much of its air away. The rivers dried, the oceans vanished, and Mars became the cold desert we see today. Beyond the rocky planets, the giants took shape. Jupiter formed first, and its timing was everything. Its solid core grew quickly until it was massive enough to pull in hydrogen and helium directly from the disk. This runaway growth made Jupiter the largest planet, with more mass than all the other planets combined. Its immense gravity carved gaps in the disk and controlled the fates of smaller worlds. Saturn formed next, built the same way as Jupiter but slightly smaller. It too captured hydrogen and helium, but its most striking feature came later: its rings. They may be the shattered remains of an icy moon torn apart by Saturn's gravity. Farther still, Uranus grew from rock and ice, but it never became massive enough to capture as much gas as its giant neighbours. Instead, it became an ice giant, rich in frozen water, ammonia and methane. Something catastrophic may have struck Uranus during its formation, knocking it onto its side and giving it a tilt unlike any other planet. Finally, Neptune formed at the edge of the disk, in the coldest regions. Like Uranus, it became an ice giant, with a thick atmosphere of hydrogen, helium and methane. Its powerful winds, the fastest in the solar system, may be fueled by the heat it still releases from its core. Each of these worlds emerged from the same cloud, but distance, size and timing sculpted them into completely different kinds of planets. Not all the material in the disk became planets. Some of it was left behind, scattered and unfinished, forming smaller worlds that still orbit the Sun today. Between Mars and Jupiter lies the asteroid belt. Here, planetesimals tried to grow into a planet, but Jupiter's immense gravity kept pulling them apart. Instead of one world, millions of rocky fragments remained, leftovers from the solar system's earliest days. Farther out, beyond Neptune, lies the Kuiper belt, a vast ring of icy bodies. Pluto, Eris, Haumea and Makemake are among its largest members, but billions of smaller icy objects drift there too. Even farther still, at the edge of the Sun's influence, stretches the Oort cloud. This spherical shell may contain trillions of icy bodies scattered far into the darkness. Some of these frozen remnants occasionally fall inward, becoming the comets we see streaking through our skies. Moons too were born from these processes. Earth's moon likely formed after a massive collision between the young Earth and a Mars-sized body named Theia. The debris from that impact gathered into a single companion, one that would shape Earth's tides, stabilize its tilt, and influence the development of life. These cosmic leftovers, asteroids, comets, and moons, may seem like fragments, but they hold the solar system's oldest memories. They are the raw ingredients from which the planets were made, preserved for billions of years. After hundreds of millions of years of chaos, the solar system began to calm down. The planets settled into more stable orbits. The constant bombardment slowed, the dust cleared, and sunlight reached the worlds more steadily. On Earth, this stability was everything. Oceans condensed from steam, forming vast blue seas. A protective atmosphere took shape, rich with nitrogen, carbon dioxide, and eventually oxygen. For the first time, the planet had a relatively calm stage where life could begin its slow, miraculous rise. The other planets too entered their settled states. Mars cooled too quickly, losing much of its atmosphere. Venus locked into a runaway greenhouse effect, transforming into a hellish inferno. But Earth landed in the just right zone, the habitable zone, where liquid water could exist for billions of years. Meanwhile, the gas giants continued their silent guardianship. Jupiter, with its immense gravity, acted as a cosmic shield, deflecting or capturing many dangerous comets and asteroids that might have otherwise struck Earth. Without Jupiter, life on our planet might never have had the time to evolve. The solar system had finally transformed from chaos into an organized family of worlds, each with its own destiny. But the story of our solar system isn't finished. Even today, it's still evolving. The planets continue to shift ever so slightly in their orbits. Moons are tugged by tides, reshaping their surfaces and sometimes hiding oceans beneath their icy shells. Saturn's rings, as majestic as they are, won't last forever. Scientists estimate they could disappear within the next 100 million years. Earth too will change. Our Sun, currently in the middle of its stable life, will one day begin to expand as it runs out of hydrogen fuel. In about 5 billion years, it will swell into a red giant, engulfing Mercury, Venus, and very likely Earth itself. The outer planets, meanwhile, may drift farther apart as the Sun loses mass and its grip weakens. But long before that, Our solar system will continue to face visitors from the outside, comets from the distant Oort cloud, asteroids passing near Earth, and perhaps even gravitational nudges from nearby stars as they pass close over millions of years. And eventually, when the sun's life ends, it will collapse into a white dwarf, a fading ember of the star that once gave us light and warmth. The surviving planets will orbit this ghost of a sun, while life, if it still exists by then, will have long since moved on. The solar system is not just our home. It is our origin, our protector, and, one day, perhaps our stepping stone to the stars.